Today we're going to talk about the real number system and a few properties. So let's start with the real number system. As you know, numbers are categorized, just like as humans we like to categorize everything. Science is all about categorizing things. In math we categorize numbers as well. And if we want to just go with the very most basic set of numbers, we call those the natural or counting numbers. And those are numbers that you can use your fingers with, like for instance 1, 2, 3, 4, etc. But then as man progressed, we came up with different ways to represent different amounts, and that led us to whole numbers. And the whole numbers include all the natural or counting numbers, okay, except for they also include the number 0. Okay, so if we go back to geometry, a good always, sometimes, never type question would be every whole number is a counting number. Well, that would be sometimes, because, or pardon me, let me say that again. A whole number is a counting number. Well, that would be sometimes, because 1, 2, 3, 4, 5, etc. would be a counting number, but the number 0 would not be. A natural number is a whole number. Well, that would be always, because these numbers are always whole numbers. Okay, so anyways, let's continue on. Then we progress to integers. Now, integers, are all of those whole numbers. So we have 0, 1, 2, 3, etc. But then we also have their opposites. So we have numbers like -1, -2, -3, etc., etc. So again, you notice that we're just building upon one number system after another. And then we have, from there, we have what we call rational numbers. Now, rational numbers are any number that you can write as a fraction. But again, if you just want to keep it simple, okay, a rational number are all these integers. Okay, you have 0, you have 1, you have 2, you have -1, etc. But then you also have numbers in between them, like the number 1/2. Okay, you have the number 1.4. Okay, you have the number -2/3, okay, etc. Okay, so rational numbers are all these numbers up here. They're natural, whole, and integers. Okay, but it also includes fractions, decimals, things like that. Then we get into the last type that we're going to talk about, okay, and that is called irrational. Now, irrational numbers are completely separate. All of these right here, all of these numbers, okay, are all kind of in the same group, if you will. Okay, because again, if you notice, rational numbers are all of these numbers plus fractions, decimals, etc. Irrational numbers are kind of those strange numbers that in lower mathematics we don't use a lot, so like the number pi. Also, we have numbers like radical 3. Okay, those would be examples of irrational numbers. Okay, now all of these numbers, okay, all of these are all part of what we call the real number system. Okay, and we'll get into some numbers later on that are called imaginary numbers, but these are all called real numbers. Okay, so again, if we go back to an always, sometimes, never type question, an irrational number is a rational number. Never. An irrational number is never a rational number. Okay. A natural number is an integer. That'd be sometimes. An integer is, a natural number is an integer. That's always, sorry. An integer is a natural number. That would be sometimes. So kind of as you're going up, okay, or pardon me, down from here, 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 okay, you're going to be an always situation. But if you go backwards, okay, or go up, okay, that would be a sometimes. Okay, so let's talk about a few properties here. Okay, now most of these properties are ones that you've already done before, you've talked about before. Okay, you have commutative property. Now there's two types, okay, of addition and then of multiplication. So let's just start with addition. Okay, commutative property would mean A plus B is equal to B plus A. So the root word there is to commute. So the way that you write an addition problem doesn't make a difference. You can write these two, or you can rewrite it like that. And with multiplication, same thing. AB is the same thing as saying BA. Then you have the associative property of addition. Okay, and that says A plus B plus C is the same thing as A plus B plus C. So it doesn't matter how you associate these numbers. You can add these first, then this, or you can add these first and then this. You'll get the same result. And multiplication, same thing. You can multiply AB and then C, or you can multiply BC and then A. Identity property of addition says if I take any number and I add 0, I'll get that number back. So in other words, its identity will not change. Okay, and as a result, people will call 0 the additive identity, because if you add 0 to anything, it doesn't change the value. And with multiplication, it's not 0, but rather it's 1. So 1 is what we call the multiplicative identity. And the inverse property of addition simply says if I add a number's inverse, we get back to the additive identity, or we get to 0. And in multiplication, if I multiply by the reciprocal, I get back to the multiplicative identity. And there you go. And that's all there is to the real number system and properties.